A great deal of processing of sequences and other iterable values uses built-in functions that take in one iterable value and give you back an iterator. So many built-in Python sequence operations return iterators that compute results lazily. What lazy computation means is that a result is only computed when it has been requested. So the interpreter gets ready to compute whatever is desired, but doesn't actually compute it unless that value is going to be used. Let me show you some examples. There's a function called map that takes in another function and an iterable, and it applies that function to each element in the iterable. But instead of applying it immediately, it returns an iterator that iterates over the values funcx for every x in the iterable. There's another built-in function, filter, which takes a predicate function and an iterable, and it iterates over x and iterable if it's the case that funcx returns a true value. Zip takes two iterables. It iterates over co-indexed xy pairs. Reversed iterates over x in a sequence in reverse order. All of these return iterators, and those iterators produce these values each time you call next on them. If you ever want to view the contents of an iterator in its entirety, you can place the resulting elements into a new container by calling list or tuple or sorted. Sorted creates a sorted list containing all of the elements in the iterable. Let's do some demos. So if I create a list B, C, D, I could uppercase all of those elements by invoking the upper method for x in BCD. I could get a similar effect by calling a map on a lambda function that computes the uppercase version of every element in BCD. But what I get is not the list, capital B, capital C, capital D, but instead a map object, which is an iterator. So if I give it the name M, then I can ask for the next uppercase letter, which is B, and then C, and then D, and then we're done. Now, how those results computed is quite interesting. Let's define a function double, which takes in x and prints out exactly when x got doubled. X is doubled into 2 times x right now, 2 times x. If I map double over the list 3, 5, 7, I get a map object, and you notice nothing was printed. So I'll give this thing the name m, and then I'll ask for the next element in m. And at that very moment, it doubles 3 to get the number 6. Not until I ask for the next element will it double 5 to get the number 10. And then finally, if I ask for the next element after that, it computes the number 14. So the point here is that double is not applied to 3 and then 5 and then 7 immediately, but instead applied lazily. Only when we ask for the next element is the function applied and the result computed. The map object that's returned when I call map can be passed into another sequence processing function. So for instance, let's say I take the range from 3 to 7. I map double over that range, and I call that m. Then I create a filter function that takes in a value y and returns true as long as y is greater than or equal to 10. I could filter using f the map object and build a new iterator from the result. Notice I still haven't doubled anything at all. If I ask for what's the next doubled element in the range from 3 to 7 that's at least 10, then it will double 3 to find that the result is 6, which is false according to our filter function. So it doubles 4 to get 8, which is also false. Then it doubles 5 to get 10, and 10 is greater than or equal to 10, so that gets returned. So you can see that it did exactly as much work as it needed to do in order to return the next element of the sequence of doubled values that are greater than or equal to 10. But it didn't do any more work than that. If I ask for the next element, then it'll just double one of them, find out it's greater than or equal to 10, and return it. And if I list the contents of T, well, it finds that there's nothing left, because this range only goes 3, 4, 5, 6. 6 doubled is 12, and then we're done. So starting from scratch, if I want to filter all of the elements of the result of mapping double over the range 3 to 7, I'll get an iterator over the values 10 and 12, which I could place in a list. And placing them in a list means that it's going to run this process to exhaustion until I reach an empty iterator at the end. And that returns the values 10 and 12. And it had to do all of the work in order to get there. It had to double every number 3, 4, 5, and 6. So it's possible to use these iterators to compute the exhaustive answer. But if you don't ask for the list of values, and you only ask for elements one at a time, then they will be computed lazily. Lazy computation is mostly convenient because it allows you to specify how to compute lots of values, but if you don't actually need all those values, then you don't bother computing them. However, there are some things to be careful of. For example, if I create a list that's the same, forward or backward, and I ask what's the reversed version of that list, what I get is a list reverse iterator object. So just saying, is the reverse of t equal to t, will give me the result false. Now, if I list out all of the contents of the reversed iterator, that's equal to t. But you want to avoid applying equality to a list and an iterator, because you'll get false. You'd have to compare a list and a list.